what is the James Webb Space Telescope? It is a large infrared telescope that's about 6.5, that has a 6.5 meter primary mirror, and it launched Christmas Day 2021. And so, yes, we're coming up on our 1 year launch anniversary. And it wasn't just NASA, but ESA and CSA, so the European Space Agency as well as the Canadian Space Agency were involved. It was named after James Webb, who was the second administrator with NASA. To me, the big deal with James Webb, the man, is that he was the one who insisted that NASA have a strong science program, that it wasn't just about flying airplanes and launching rockets, but it was all about the science. So in looking and finding out those all about the science, that's where Webb directed NASA. And as an educator, I'm so grateful. Of course, the successor to Hubble, but a lot of people like to compare the two. And so I've got a couple of different slides. And when I created this PowerPoint, I really created these with the educator in mind so that you can literally take these PowerPoints and use them as you see fit. Keep what you need to, delete what you don't. So, you may find that there's a couple of different repeated slides in here. So this one here is talking some comparison. If we go forward a slide, it's another way at looking Hubble for scale. This one is very obviously visual oriented. Hubble is more like a tennis court, where James Webb is more like a tennis court, where Hubble is more like a school bus. And then there to the right, the primary mirrors, Hubble's about the size of a human, whereas James Webb is considerably bigger. Again, you can go back and take a look at the actual data. So either one of these slides, whatever works best for you. In talking about wavelengths, NASA has several different programs out there that are looking into the cosmos. You've got James Webb, we've got the Roman, Euclid, Hubble, the Chandra, which was an X-ray telescope. You've got some land-based. And then you also had Sophia. Of course, Sophia just retired, but that was an airplane-based telescope, which was pretty kind of neat. So when you talk about looking at space, it's typically in looking at different types of wavelengths. And so when you talk about wavelengths and what you can observe with them, what primarily we think about whenever we talk about what we can see is visible light. Or if you'll think about the rainbow and Roy G. Biv, that's the visible light. And, we can see planets and the majority of stars with visible light. But as you go out from there, whether you go to gamma ray, X-ray, ultraviolets, and the different things you can see, or even to the other side, infrared, microwave, and radio, there's different items that you can observe with that. In addition to this slide, I've got another one that takes a look at what Hubble, James Webb, and even Spitzer, the different aspects that it's looking at. And part of the focus here, in particular James Webb, is that we're looking at these infrared rays. And if you go back to this description, infrared is looking at cool stars, warm gas. We're basically looking at objects that are hidden behind cold dust. But more importantly, the reason we're interested so much in those infrared waves is what's called the cosmological redshift. That's the wavelength at which the radiation is originally emitted. That's been lengthened as it travels through space because space is expanding. And this cosmological redshift itself, and not from the motion of any individual body. So as light travels through expanding space, it stretches it into longer wavelengths. And as we do that, what you're finding out is that we need to go back and take a look at that infrared to be able to look better back in time. So I'm going to click over right quick to a infrared about the redshift. I've posted the link to this video in the chat. So if you have issues with this video that's playing, feel free to click on it in the chat and watch it there.
Distant in space we look, the further back we're looking in time. And so we're designing the James Webb Space Telescope to see past the point where Hubble could see, and to see the very first stars and galaxies to light up after the Big Bang. The James Webb Space Telescope is designed as an infrared telescope because infrared is really where the key science questions will be answered. To see those very, very distant galaxies, the light from those galaxies has been redshifted. The expansion of the universe sort of stretches space-time. The light from the galaxies gets stretched as well. And so longer wavelengths of light are redder. And so at some point in the very distant past, the light from those galaxies has been shifted, redshifted, all the way out of the visible spectrum to the infrared part of the spectrum. So having an infrared telescope in space is one of the things that's going to allow us to see those very first galaxies.
So looking back in time is what allows us to be able to see that red shift. And what is infrared light? Primarily the way we understand infrared light is through heat. Our eyes aren't really sensitive enough to see it. As a matter of fact, as you look at this particular item on the left-hand side of the slide here, what do you think that is? Do me a favor, in the chat, go ahead and type in what you think that is over here to the left-hand side. So it's taken in infrared light. And so I've got some people that are saying it's a cat, you know, and so we're taking a look at this here in terms of, and so from that, you can see the colder regions and the different colors that come with that, possibly a dog. Okay. Anybody else have recommendations of what they think that might be? And the truth of the matter is, you know, maybe a raccoon. Yeah. Maybe a fox, maybe, you know, I'm not sure. And the reason is because it's in infrared, and I'm not used to seeing things in infrared. I'm used to seeing things in visible light. And so, but you can see the very hot portions, or where the eyes are, where the mouth is, where the ears are. And so we can, yeah, kind of wide for a cat, you know, and I don't, you know, Dolores, I'm honestly not sure what this is. However, if you take a look at this, it's another way of looking at it. And it's how we perceive infrared more as heat radiation as opposed to visible light. And so this one here gives you, you can see that, you know, what you're really looking at, the meerkats on the top and the giraffe on the bottom. That previous one, I'm just not sure. But it's important to understand that whenever we talk infrared, really what we're talking about is heat. And that's how we primarily see it. Now, there is a video that talks about infrared waves, and NASA has an EMS video. If you're not familiar with the electromagnetic spectrum video series, I would highly recommend it. I'm going to show a few minutes of this video. It's about 5 minutes long, but I'm not going to show it all. We're just going to watch a few minutes of this. Again, just giving us some more background.
Determine the Earth's total radiation budget. Other NASA instruments monitor the changes in other aspects of the Earth's climate system, such as clouds, aerosol particles, or surface reflectivity, and scientists are examining their many interactions with the energy budget. A portion of solar radiation from the sun that is just beyond the visible spectrum is referred to as near-infrared. Scientists can study how this radiation reflects off the Earth's surface to understand changes in land cover, such as growth of cities or changes in vegetation. Our eyes perceive a leaf as green because wavelengths in the green region of the visible light spectrum are reflected, while other visible wavelengths are absorbed. Yet the chlorophyll and the cell structure of the leaf are also reflecting near-infrared light we cannot see. This reflected near-infrared radiation can be sensed by satellites, allowing scientists to study vegetation from space. Using these data, scientists can identify some types of trees, can examine the health of forests, and can even monitor the health of vegetation, such as forests infested with pine beetles or crops affected by drought. Studying the emission and reflection of infrared waves helps us to understand the Earth system and its energy budget. Near-infrared data can also help scientists study land cover such as changes in snow, ice, forests, urbanization, and agriculture. Scientists are beginning to unlock the mysteries of cooler objects across the universe such as planets, cool stars, nebulae, and much more using infrared waves.
Okay, and I'm going to pause there because, again, I know our focus is not so much the science, and I want to, not that science doesn't matter, because it does, but that takes you into an excellent demo that they provide. And I will tell you that there's an entire series on the electromagnetic spectrum. If you look in the notes section of this slide, it'll tell you about a NASA activities series that's on the electromagnetic spectrum. But again, what we're looking at is that infrared system with Webb, and it's one of the reasons that it's going to bring such rich photos to us. Again, talking about the predecessor, Hubble. Hubble in one of its amazing photos came from an ultra deep field, and it took 11 days for combined exposure. Basically, they sent it to one of the, what they thought was the darkest spots in space where it was looking at, and just left the shutter open for 11 days. It's a little bit more complicated than that, but yes. And then that's what they discovered. And this video here talks about the visual exploration of Hubble's deep space. And as we're talking about art, I think that this understanding the ultra deep field really helps to bring in some of the amazing discoveries that are there. So I've put the link in the chat. And then, so if there's issues with this video, feel free to click on the link. Otherwise, we're going to watch this here about the ultra deep field. think that's just absolutely amazing. I think I could watch something like that all day. Yes, absolutely mind blowing. And so as we look out there with the ultra deep field and what Hubble was able to see, it's only the beginning. But it only takes us so far back. And again, that reasoning for why that infrared is so key and so important. And the excitement, in my opinion, of how much more Webb is going to help us to discover. And so as we look into the past, again, another infographic here to see and show where Hubble's limit was, but that how truly our first galaxies forming is where Webb is going to take us. Having said that, we're looking at the birthplace of stars and of planets and other worlds. And this is going to tie in nicely whenever we think about looking out into the cosmos and how that art fits in with this cosmic connection. And so what are these different things that we see and observe, and what do they mean? And these are just some beautiful photos that JPL has had made. So you've got the launch. I've got a lot of slides in here. I'm just going to kind of glaze over so you can use them as you need. But this here is Webb's amazing sun shield. And you can see it's kind of origamied up there. But one side of the sun shield is negative 235. And then the outer layer is 125. So you're talking 2, 3, almost 360 degrees difference from one side to the other. And what makes that so key is because of the infrared. Infrared measures heat. So on the side where Webb is doing the observations, it needs to be as cold as possible so that it doesn't pick up heat from the actual satellite, which to me is just amazing that you could have 360 degrees literally difference. A photo of the launch, again, that occurred Christmas Day. And just a few more photos just because, wow. Anyway, this was the unfurling. And so as you can see, Webb was tightly collapsed. And this is the last photo as Webb heads out to deep space. There was an unfolding sequence to it. And in the notes section of these slides, there's so much more. But again, this PowerPoint is probably more about science, where I really wanted to focus more today on the arts. And so it is by all means the most sophisticated tripod. I'm trying to say that twice. If you've not checked out Where is Webb, you can go to web.nasa.gov/where is Webb. And there's actually a timeline across the bottom that allows you to go back and forth. So if you want to go back to day 2, day 3 of Webb out in space, you can do that, which is absolutely amazing. Webb is currently at Lagrange point 2, about 1.5 million kilometers from Earth, or roughly 1 million miles. And that's where it will hang. There's various components on the satellite, but this was the first alignment evaluation image. So it focused on just one star. And as Webb was focusing on this one star, one of the administrators says, yeah, we were taking a picture of a star, and in the process, we got photo bombed by, several different galaxies. You're important. I will say that you can see from this particular photo, you can see these 6 spokes, sometimes 8. And Webb photos often have those different photo marks coming out. That's kind of unique to Webb with the honeycomb design. And so there's a video that talks about reaching its milestone. For the sake of time, I'm not going to show you that video, but I will show you some of the first images. So again, you can note how that these bright stars have those kind of 6 spokes of lights coming off of them. And that is characteristic of Webb. And so you can see Webb compared to Hubble, kind of looking at the exact same image. This is called the Cartwell Galaxy. This one here, new perspectives of what, the left is Hubble. Again, the right is Webb. Again, you can take a look and see kind of 6, 8 spoke star coming off there. Same process here, the exact same thing, but oh, how much more you can see. Just different perspectives. Taking a look at Jupiter and the images from that. And then what I love about the science is they actually label these for you. We've actually found out that Neptune has rings. Now, they have taken some photos and overlaid it with Chandra's X-ray vision. And you'll notice these are kind of boxy, and that's because Chandra's images are in a box. And so they've overlaid this with Chandra and with those X-rays, which is just, I mean, my goodness, talk about artistic. I struggle for words on some of these. The pillars of creation, Hubble to the left, Webb to the right. Again, Hubble, you can see you've got like the 4, but with Webb, it's more like 6 whenever you're looking at that. So again, more indicative of the just, how to quickly know, hey, am I looking at a Webb photo or something else? Does it give you that 6-pointer? So you can see so many more images from Webb, and there's a multimedia gallery. This gallery gives you descriptions and so forth with it, but you can also go straight to the Flickr site for James Webb. So this site gives you more info about the photos. This one here just shows you the photos. There's info there as well, but there's so much more. And so elements of Webb series videos, and I'm going to stop here on this PowerPoint because it goes into some other activities. Whenever you get to the end of today's session, you'll still be able to download all of that presentation. So even though that presentation was going to go and talk some about the chemicals and so forth, we're going to transition now, and I want the application to be more about the arts. And so we're going to look at art and the cosmic connection in that particular activity. And so with that, so you're kind of getting a 2-for-1 here today. So International Space Station is art. So the International Space Station has been up flying for over 2 decades. As a matter of fact, most students who are in school today have never known a time whenever all humans were on Earth. And so they've actually done some International Space Station as art. And so this is a video with that. So as we transition over into the art portion of today's presentation, I want to start by looking at the space station as art. And so the link is there, or you can just watch it as we go along here.
Subscribe for more space.
Excuse me. Just amazing things to look at here. So again, as we transition over into the art portion of that, science inspires art, or maybe you could say art is inspired by science. But either way, there's definitely connections between the two. They're very different, but they do carry and share some common attributes. And this particular activity called Art and the Cosmic Connection does bring some of those things together. It does STEAM, so that is the science, technology, engineering, math, but also the arts in there. It's good from kindergarten through retirement, and I have used this at some retirement homes. I think people of all ages enjoy expressing themselves through art. And it actually does bring it into the science and the arts together. And so if you think about the overall lesson, what do you know about the solar system? And just, start from there. What do you know about the solar system? You can talk about, the number of planets that are out there. You can talk about the different exoplanets or asteroids or comets, or the fact that we have rovers out there, or that there's galaxies and stars, and I mean there's just so much. But just as an opening, there's moons, there's asteroids, there's comets, some of the coolest and also some of the weirdest bodies in the solar system. There are robotic photographers. And so we've seen some amazing photos in the past couple of weeks, having watched the Orion go around the moon. I'm so excited about all of that. That's a whole different story. And there's even art meets science in a photo Pluto aerial tour. For the sake of time, we're not going to watch this video, but there is a little video that you can watch in that regard. But in talking about art aspects of things, and if I have anyone on here that teaches art, can you tell me, or, whenever we talk about the elements of art, I know they may sometimes be described in different order, but line, shape, color, value, and texture. Those 5 are typically the elements that give us the basis for art. And do I have any art teachers out there that you would say, yes, these are the 5 areas that we focus on? Or do I have someone that would say, well, we do it this way or we do it that way? But whenever we talk about art, are these the main 5 elements that you talk about with art? I don't see anybody typing there, which may mean we don't have any art teachers here with us today. Or it may mean that no one wants to share. But I will say I was discussing this with a teacher friend of mine, her daughter, and whenever we were talking about the fact of talking about art in the science classroom, and she's just like, no, our teacher's here. Okay, and that's fine. That's fine. And she's just like, what do you know about art? And she was talking about, she was a middle schooler. So, middle schoolers kind of know everything. And she's just like, you're talking about art. I mean, I actually take an art class. And as I talked about the different elements, and she's just like, those are not the elements of art. Those are, and what she had done is she had them in a different order. And so we wrote them down, and I had her compare, and she's just like, ooh, you really are talking about what we teach in art class. And so whenever we look at line, shape, color, value, and texture, there are elements of those art that relate to planetary images and images within our solar system that tell us about different things. So whenever we look at shape, circles are indicative of craters. And so whenever we take and we look and we see a circle on something within our solar system, typically, it's a crater that's probably from a meteoroid or an asteroid or a comet hitting the surface or a planet. And that typically leaves a circle. It also kicks up a lot of debris from the impact site that's known as ejecta, and that creates a blanket. But as you can see here, this is a beautiful picture from one of the craters on Mars. Here's looking at some of those same circles on Mercury. And the right one, by the way, it's the exact same photo. It's just the one on the right has been colorized. Again, more photos from Mercury. So just talking about different types of craters and how that whenever we see circles out in space, that's indicative of craters, whether we're talking about the moon, whether we're talking Mars, even here on Earth. We've got the big, huge crater out in Arizona. There's craters on Venus. Additional shapes, we'll call them blobs. And typically, whenever you see a blob type shape, it's indicative of either a volcano or lake. Excuse me. So as we look at Jupiter's moon, you can see some of those blobs. Same deal with Venus, Titan, even on Mars. Again, we're wondering, what type of liquid was out there? Was that some sort of volcano? Was that lava? Was it a lake? Some type of water? The other thing would be with lines, and straight lines are indicative of tectonic activity. And Europa has some, and these straight lines could be tectonic, but Europa, which is one of Jupiter's moons, this is actually ice, and that, yeah, exactly. It does look abstract to some degree, but it is actually real life. So some of the cracks here that you're seeing is actually ice. So it's not tectonic in nature, but it's but on Mars you'll see those lines, and those are indicative of fractures or faults. Talking about tectonic activity, although we think that the tectonic activity on Mars has subsided. Venus, again, you've got some more straight lines there. So potential volcanic, or tectonic activity. Squiggly lines. We've talked about straight lines. When scientists see squiggly lines, what they think about is erosion. And whenever you think about erosion, that could either be done by wind or by liquid. And so wind erosion or potentially liquid erosion. So if you've got squiggly marks, this is a beautiful picture of a delta. And in looking at that, this one's actually the Lena River Delta in Russia, taken from space. But look at all those squiggly lines. And it has a lot to do with water. So indicative there of the flow of water. On Mars, we've got a bunch of squiggly lines. And again, that makes scientists wonder, hey, has there ever been water flow or liquid water on Mars? We know we can't, we've yet to see that today on Mars. But seeing those squiggly lines make us wonder, was it once there? And again, the different colorizations that go with that. And squiggly lines don't just mean erosions, but it could also be wind erosion. We know that, oh, that is cool, Dolores, I didn't know that. Mars has a lot of wind and dust storms, so it could be that as well. There's just so much more. And by the way, in the notes section of all of these PowerPoints, there is so much more information about all of the slides. I know I'm going quickly over them. I typically would do Art and the Cosmic Connection by itself, or I would do James Webb by itself. And what I decided today was to put them both together and shove it all in. So the third thing, in addition to shape, is looking at color. And so whenever you take a look at an image, we're talking about true color as far as like what our eyes sees. But scientists can use color as an important tool to help understand planetary surfaces. They can use it from different types of light. Like we talked about with James Webb, being able to look at infrared. You could also look at ultraviolet, just different phases. So while the moon there on the left is in black and white, the one on the right has been what's called translated colors. And the translated colors is helpful for interpreting the surface soil composition. So you can see what different types of minerals are there, which to me is just absolutely fascinating. This one here, Vesta, this is from the Dawn spacecraft. The image on the left is infrared filters, and the image on the right uses color to represent different types of rocks and minerals that are present. Venus here has been color coded to represent the elevations of the different parts of the surfaces. So think like a topographical map. Huh. This stunning enhanced color image from Mars is looking at the nature of the ground surface. I mean, to me, I can just see water flowing there, and the color really helps to just enhance the texture. This is Mars in infrared light. And so it was made from images taken from infrared wavelengths in the daytime and nighttime by a Themis camera, which is a thermal emission imaging system. I mean, it's just, you can see various hot spots. But again, so much art in this. And then value is really talking about the light and the dark, the ability to shade and highlight. And so whenever you think about the reflectivity of surfaces, this here impetus, often called the yin yang moon, it's got the most intense value contrast in the solar system. Half of its surface is bright white, and the other half is as dark as black velvet. Things are bright white are very reflective, and they often mean they're composed of like ice. It's the yin yang moon. Give me 1 second. I do not have that in my notes. And so what I would need to do is a quick Google search on that. And it is a moon of Saturn. It is the 24th moon of Saturn's known 83 moons. Amazing what Google will give us there quickly. Thanks. And Carrie, thank you for bringing that into us. Another one here, the polar regions of Mars. Interesting process going on between, water, carbon dioxide, ice, and sublimation, which produces captivating images here of both light and dark. It almost looks like something biological under a microscope. Another intriguing, this is the Martian pole. Kind of looks like spider-like shapes. Bizarre, I would think. Almost looks biological in appearance. And then texture. And texture is the quality of the surface. So looking at the texture of a planetary surface can give scientists clues as to its geological story. This is Triton, an icy moon of Neptune. It's the 7th largest in the solar system, and scientists believe that this far out from the sun, that it's so cold that it wouldn't have geological activity. However, whenever they got images of Triton and they saw this weird texture, kind of reminds me of cantaloupe. And scientists have found that even though it is so far away from the sun, that they believe there's evidence of geysers and cryovolcanoes. And whenever I say cryovolcanoes, I'm talking about ice volcanoes. So not so much lava, but ice that spewts out, which is just mind-blowing to me. Again, another image of Mars South Pole, pitted with texture. They call this the Swiss cheese terrain, that hints of sublimation of underground carbon dioxide. It's just amazing to me, these different types of textures. Here, so many different polygon shapes, sort of a, quote, patterned ground because of the edges. I mean, there's just so many different ways in looking at and within the different elements of art. And here you can deciphering geological stories on Mars. This one here, they have colorized it. You can see circles with the craters. You can see blobs, which are indicative of volcanoes. You can see the squiggly lines, which could be either river channels, possibly water erosion or wind. You can see straight lines with tectonic activity. And they have also colorized it, indicating elevation. But you can also kind of, I mean, I can just see kind of the water flowing on the ancient surface of Mars here. And so even though we're bringing in all of those different elements of art, there are scientific implications to them as well. So, and it's not just the solar system, but there's also videos out there as well. And this is one about Earth as art. Let me see if I got that one. Yeah, the top 5. So let me show you that. I think this was actually from 2013, but it still fits. So we'll take a look at these top 5. And if you need the video link, it's there. And we'll
A
come
series
back
of
and wrap this up.
Landsat satellites have surveyed the Earth's surface since 1972. In that time, Landsat data have become a vital reference worldwide, used for understanding scientific issues related to land use and natural resources. However, some Landsat images are simply striking to look at, presenting spectacular views of mountains and valleys, forests and farms. To celebrate the 40th anniversary of Landsat, the U.S. Geological Survey and NASA asked for your help in selecting the top 5 Earth is Art images. Number 5. Lake Eyre. Patches of shallow water in Australia's Lake Eyre resemble a skull. This ephemeral feature occurs in a flat, often parched landscape. Lake Eyre is Australia's largest lake when it's full. However, in the last 150 years, Lake Eyre has only been full 3 times. Number 4. Algerian Abstract. What looks like pale yellow streaks of paint slashing through a mosaic of mottled colors are ridges of wind-blown sand that make up a sea of sand extending from Algeria into Mauritania in northwestern Africa. In this area of ever-shifting sand, one of several in the Sahara, individual dunes often surpass 500 meters, nearly a third of a mile, in both width and height. The light blue areas in the image are salt crusts left behind from the evaporation of the valley's water. Number 3. Meandering Mississippi. Small blocky shapes of towns, fields, and pastures surround the graceful swirls and whirls of the Mississippi River. Numerous oxbow lakes and cutoffs run along the meandering river south of Memphis, Tennessee, on the border between Arkansas and Mississippi. The mighty Mississippi is the largest river system in North America. Number 2. Yukon Delta. Beginning in British Columbia and flowing through Yukon in Canada, the Yukon River crosses Alaska before emptying into the Bering Sea. Countless lakes, sloughs, and ponds are scattered throughout the scene of the Yukon Delta. The sinuous branching waterways resemble blood vessels reaching out to enclose an organ. It is one of the largest river deltas in the world and is protected as part of the Yukon Delta National Wildlife Refuge. Number 1. Van Gogh from Space. In the style of Van Gogh's painting Starry Night, massive congregations of greenish phytoplankton swirl in the dark water around Gotland, a Swedish island in the Baltic Sea. Phytoplankton are microscopic marine plants that form the first link in nearly all ocean food chains. Population explosions, or blooms of phytoplankton, like the one shown here, occur when deep currents bring nutrients up to sunlit surface waters, fueling the growth and reproduction of these tiny plants.
And I hope that while you were looking at those photos, you were able to recognize some of the different elements of art that we had been talking about. I saw definitely some squiggly lines and straight lines. So for your art activity, choose any sort of planetary photo. You can choose one photo that every kid in the class does, or you could have different photos that everyone could Mohammed, I have no idea what you're asking about. Sorry. But in doing the art activity, you have the students to focus on, and whether you do one group often around the Earthrise photo. So sometimes I'll put that photo up and then pass out black construction paper and chalk and have all the students do the Earthrise photo. Sometimes I'll just have out a whole list of different photos from different images of planets and moons and bodies, and have the students draw. And while you can do this with all sorts of different classes, you can do it with crayons, you can do it with pastels. There's really no limit to what you can use to create with. Um, and honestly, you can even do it with adults, um, and just let them discover. Now, I personally tend to use more of construction paper, and I love using chalk because those are both cheap, and you don't have to worry about getting a very precise, perfect picture because construction paper is a little rough. Now, if you want to, you can see here the lower left-hand picture. There's an adult fine arts center. You can see they've done some 3D. You see they've done some on um, Canvas, but students can also just do them on regular paper. They can use different ways that you can do that. And so you've got different pieces of cloth that they're putting together here that looks like they're making a 3D image of it. Here they're using yarn. There is no limit to how you can use this. And whether you're using James Webb Space Telescope photos, whether you're looking at images from across the universe, and I've got several of those for you to download here at the end. But there's an entire toolkit that goes along with this, and just have fun. Anyone can teach the value part of the art a little bit. Okay, so whenever we're talking value, what you're talking, give me 1 second, let me figure out what slide that is. It's referring to basically color 39. So let me go to slide 39. So whenever we're talking about light and dark, shade and highlights, so whenever you're talking about value, that's talking about like the difference in color. So if you'll think if it's just black and white, that means there's no gray. And that gray is the contrast between, the light and the dark, or the areas between the light and the dark. And so here you've got dark and light. And so the distribution of the color differences, if it's all the same color, it's more difficult to see. But where you add value is where you add in that contrast, if that makes sense. Does that help, Andrew? Okay, great. Perfect for your STEAM program. I'll talk about that. Have you considered using the hand-colored Mariner? There's nothing wrong with that. You can use Mariner 4. There is literally no limit as to what you can use for those images, which is one of the reasons that I wanted to show this. You can see sometimes they're using images of Earth, sometimes they're using images of space, sometimes it's of the moon. There's no limit. There literally is none. There are additional videos that you can look at that tell you more and will give you more information about it.